Continental drift versus tectonic plates.
Good morning to each and everyone, and especially to you, sir. My name is Michael M. Skak, together with my partner, Redalis Chablo. So now, our topic to be discussed is all about the continental drift versus tectonic plates. So before formally started our discussion, I would like to introduce our objectives for today. First objective is to define continental drift and tectonic plate. The second one is to determine continental drift and tectonic plates. The third objectives is to differentiate continental drift and tectonic plates. So now we're going to discuss or tackle about plate tectonics versus continental drift. So when you say plate tectonic, a plate tectonic is the theory in geology that describes the features and movement of the earths and surfaces in the present and in the past times. So Earth's lithosphere is a composed of different plates, and they began to move along time. The presence of the seven major continents and the small islands to prove for the plate tectonic. So that's the plate tectonic. While the continental drift is the theory in geology that describes the drifting of the Earth and environment on the ocean. Aside from that, there are continents on the Earth which have a drifted on the ocean bed. So the occurrence of similar plants and animal species around the shores of different continents proves continental drift theory. So that's the difference between tectonic plates and continental drift. So these tectonic plates and continental drift, this continent proposed by this continent were once assembled together as a single continental by Alfred Wegener. Then he named it as a Pangea. So according to this theory, this continent drift, the world was made up of a single continent. Through most of geologic time, that continent is forming into 7 continents where we have today. The first comprehensive theory of continental drift was suggested by Alfred Wegener in 1912. Tectonic theory rather, science believe that the Earth's surface is broken into a number of shifting slabs for plates, which average about 50 minutes thickness. These plates move relative to one another, often hotter, differ, more mobilized zone or average rates as a few inches per year. Most of the world's active volcanoes are located along or near the boundaries between shifting plates and are called plate boundary volcanoes. So these plate tectonics are shifting, and it is called as a volcanic boundaries. So now, 3 things to describe the continental drift. So here are the evidences to prove that the continental drift. Wegener saw that the coastline of North America and Europe and Africa appeared to fit together. So according to Wegener, this continent was that the coastline of it, that the Europe and America was affaired or fit to each other. So as you can see in the picture, this was the continent, 7 continent, which is continental drift, which is the continental drift is moving apart. So the another evidences for continental drift, animal fossils match between different continents. So as you can see in the picture, as I mentioned, so in every continent there has a same animals who could live, until now. So there was the same animals which is found in different continents. So through continental drift, so we can see in the picture where was the animals living in the different continents. So that was the evidences talks about the continental drifts. So the third evidences for continental drift, so Alfred Wegener, this led Wegener to conclusion that the all continent moves or all continents were once joined.
50 years continental drift was left, where it was but the Harry Haas, a naval officer during World War II, was doing some scans of the ocean floor and he didn't realize it, but he was about to become the father of plate tectonics because Harry Haas made a very important discovery and he was looking in a place that Wegener never thought to check the ocean floor. What he discovered during his scans and sonar readings of the ocean floor was that he ran into the middle of Atlantic Ocean, a long range of mountains, something he never expected to find. And at the peak of these mountains were volcanoes, so part of our Earth's asthenosphere is being burped up along the edges, here forming new ocean crust right where the volcano is, and farther sometimes magnetic pole data of the ocean floor confirmed the idea that not only was magma coming through a crack in the ground. The left side of the crack was actually moving away from the volcano and also the right side of the crack. The sea floor was spreading through dating the ocean. The rocks that make up the ocean floor, we have been able to uncover that the edge of rock close to volcano, which is the middle of this seam that runs all the way through the Atlantic Ocean. These edges are a lot younger and the rocks out on the far edges, farthest away from the volcano. Those are the oldest rocks. Therefore, the seafloor is spreading. So how does seafloor spreading work? Well, it works the heat from the inner and the outer core allows the asthenosphere and mesosphere material to convect, and wherever you have the upward motion of convection, that materials is going to split left and right. Once it reaches the top, well, splitting motion is what allows the tectonic plate above it to move in opposite direction or diverge. And wherever you're going to have convective material that becomes cooler and more dense, so it begins to sink. That sinking motion is going to drag the lithosphere above it, and it's going to subduct or converge another boundary and sink down into the middle materials to be recycled. So if ocean floor is being created or being generated here, ocean floor is being reconciled somewhere else, and that allows sea floor to spread in one area but get consumed in other area. Two different views of the interior of the Earth. Mechanical. The mechanical layers of the Earth are differentiated by their strength or rigidity. These layers are not the same as the compositional layers of the Earth, such as the crust, mantle, and core, though sometimes the boundaries fall in the same places. The planet. The outer layer of the Earth, composed of solid rock, is called the crust. At a depth of 10 to 70 kilometers, the crust is very thin. On the scale of Earth as a whole, the crust sits on the mantle, which takes up 80% of the planet's volume. The upper part of the mantle is rigid, while the greater depths, the rock is partially melted at temperatures as high as 3,000 degrees Celsius. Finally, the center of Earth is called the core. It is an extremely dense area composed mainly of metals, where the temperature is above 6,000 degrees Celsius. Part of this heat carried by the slow movement of molten matter rises toward the surface and warms Earth's crust. Compositional, the outermost solid layer of a rocky planet or natural satellite, chemically distinct from the underlying mantle, a layer of the Earth or any planet large enough to support internal stratification between the crust and the outer core. It is chemically distinct from the crust and the outer core. The plate tectonics theory is based on concepts proposed by Alfred Wegener. The lithosphere is divided into continent-sized plates that are constantly moving. The continents were once part of supercontinent called Pangaea. Volcanoes, mountains form as a result of convergent boundaries colliding. Earthquakes and tsunamis occur at convergent and transform boundaries. Fissures, cracks, and drift in the surface occur at divergent boundaries. Seafloor spreading occurs the divergent boundaries on the ocean floor. Boundaries are where plates met. Three types of plate tectonic boundaries. So first, convergent, where plates collide. Second, transform, where plates slide past one another. The third is divergent, where plates move apart.
So now we have three types of boundaries. They were all plates. So the three types of boundaries: first, convergent boundaries, transform boundaries, divergent boundary. When you say convergent boundary, these boundaries where plates are collide. While the transform boundaries, there were plates collide, slide, move fast one another. And the divergent is there were plates move apart. So that's the difference of three types of plate. What is convergent boundaries? So when you say convergent boundaries, occurs when two boundaries or plates collide, and there are three major types of boundaries. First, continental to continental. This occur when two plates continental crust collide. They buckled and tickled, and this causes mountain to form. The next is the continental ocean collision. When a plate of ocean crust collides with a plate of continental crust, the ocean crust is more thick, and it should be the magma of the ocean rises to the surface of this matter, and this result volcanoes along the boundaries ocean to ocean collision, and it will occur when two plates ocean crust collide. So that's the convergent boundary. So let's move to divergent boundaries. So the divergent boundaries, this is when two plates move away from each other. So the difference is, while the convergent a while ago, they are the convergent boundaries, they are meet each other, and while these divergent boundaries, this place is moved away from each other, and the separations allow the asthenosphere to rise towards the surface, and partially it melting to create magma, which is erupt as a lava. Then the lava cools and has dents to create new rock, an ocean floor, or new continental crust. That's the crust. Upper part of the asthenosphere cool, become rigid. They form new lithosphere. So like mid-ocean and ridges, it must be divergent boundaries are located on the ocean floor. Now, overlift valleys may also form where continents are separated by plate movement. So that's the divergent boundaries. Both divergent boundaries and convergent boundaries are produce magma. So the number three types of boundaries are transform boundaries. So the last types of transform boundaries is occur when two plates move past each other horizontally, and when the plates move next to each other, they do not go along smoothly. And steadily, they scrape of each other is a series of a sudden seepage or the crustal rock, and this can be felt as an earthquake. So, these transform boundaries do not produce magma, unlike convergent boundaries and divergent boundaries, they produce magma. So, the biggest example of this transform boundaries is the San Andres Fault in California. This is the major transform boundaries happen in the world. So, that's the examples of the transform boundaries.
That would be all. Thank you for listening.